Perfect. Thank you. Good afternoon, everyone. My name is Renaud Drouin. I'm from, Hydro-Quebec. I'll be presenting you today the automated validation that we did using DTM. A couple years back, I set that up, but it's still in use today. So we'll go over. You can change slide, Jackson. So we'll go over the why automatic testing was used for pretty much obvious reasons. The testing environment that we set up and that we deployed, what were the automatic testing that we did, and how the rolling out of that automatic testing went in the later stages. So why did we do some automatic testing? Well, it all started now it's almost 10 years. There was a complete overhaul of the architecture of the protection and control systems that we deployed at Hydro-Quebec. This new architecture was mostly based on 61850. There was some legacy protocols, but I think it was only DNP3 that was used for the different components that was not compatible with 61850. With the overall of this architecture and the change in philosophy came to the testing and how we could test the system. We implemented the 61850 using a common data model. You can change slide, Jackson. Yes, thanks. So we implemented a new data model with new protection philosophies, combining the control and the protection within the same equipments in order to simplify the different IDs that were used, simplify the network, as well as merging the different functions that we have for the station functions, mostly the local automations, the HMI, and the gateway. So with this new architecture, there was a rethinking of how this validation could be done with more efficiency. And we came across one of the tools of Triangle MicroWorks, which is DTM, Distributed Testing Manager, if I'm not mistaken. DTM, which enabled us to do this automatic testing of almost the complete systems, but in some cases to be more reliable in terms of testing, because automated testing, sorry, always looks at the same conditions, and it's normal as a human being while testing thousands of signals or hundreds or thousands to be distracted at one point, that it's not always 100% that you look at all the signals and that you're always having a complete focus on the testing, on the results, especially when looking at very detailed information that can come up to the screen. It can be much more scrupulous, meaning that we can look at much more conditions that if you look at a signal, especially in 61850 with the richness of that the data offers, that you can have the signals. Yes, you have its status, whether it's a Boolean, it's true or false, but then you have the time tag, you have the quality. Automatic testing can go look at a specific number of different attributes for that same signals and always look, is that signal in line with what I'm testing at that point. Plus, it's much more efficient that with the automated validation that we did, we were analyzing around 5,000 signals in 7 or 8 minutes. Somebody by hand would with manual validation, it would take days, if not weeks, to test that number of signals. So the testing environment, if you can go to the next slide. We had this architecture, which is a simplified version of the architecture, but it has the main components that at the bottom, like I said, we merge for each different base the protection and the control of the associated device. Meaning that for the line, well, we had redundancy, so protection A and B that in most cases were on the same network. In some cases, they were separated. But we had the line protection, transformer protections, all of those were within the same IED. For our station network, then following some design changes, we separated the local unit for local automations, which we call the UAL, in order to have the local automations, but his catalog of functions grew over time, and we included the backup station HMI in there as well. So it had really different interactions with all the different IDs, pretty much only by Goose towards all the different IDs. So it had a bunch of exchange back and forth in order to have the status, in order to take the information and apply the local automations. And we add on virtual machines the local HMI and gateway, which were merged, which we call the UCCT. And because it was a virtual machine, it allowed us to have other virtual machine within the same hardware to have our maintenance bay that is a engineering desktop, or depending on how you call it, which had all the different tools in order to configure the IEDs, configure the different different components of the system. We had debug tools in there as well, and we had our simulation bay on which DTM was hosted in order to have the different interactions with the different components in order to select between the real components, the real IEDs within the system, or the simulated one within DTMs. We had a Ethernet adapter switch within the virtual machine in order to switch between the real equipments or the simulated one. Mostly, well, for the different validations. So when we came to validate the different components, Jackson, you can go to the next slide, please. We had different setups to validate the different interactions between the components of the system. We had the physical interface of the process with the IEDs. So each process level IEDs, so the protections for each of the different bays with their physical interface with the process. We had the Goose exchange across the different IEDs. So for the different IEDs and with the UAL mostly. And we had all the MMS reporting from all the IEDs towards the local HMI and gateway, which are housed in the UCCT. So with this was to have the complete solution and the complete validation of the system. So the first one was can you change slide, please? The first was the validation of the IEDs. So this was done with an injection test set, such as Omicron, Doble, or Manta, that was able to inject physical signals within the protection and analyze and validate that the interaction within the 61850 data model was done correctly. So all of this was automated based on the different tools that we had, meaning that for a specific case of a protection trip, we were expecting to have the corresponding signals coming. So we were validating the goose going out, the goose going in, and we were testing all the different cases of the protections. This is not outside the box. This is something we did. Well, we always do, but this was automated in order to validate that the communication interface was always standardized and they were validated in all the cases of the test plan. The second setup, so if you can change slide, was the goose exchange across the different IDs. So now it comes more on the 61850 interactions. So with the goose, most of it was across the IEDs and with the UAL. So we use the Triangle Microworks in order to subscribe to the different goose and publish the different goose, and with specific scripts that were based, I think, on Java. We simulated the different cases and we expected to see the different behavior from the different IDs based on the published goose. So in a lot of cases, uh, yeah, so we'll see a bit later how the results were analyzed, but the goal was to get all the reactions from the IDs based on the different cases. So on when importing the SCD within DTM, we were able to identify which signals could be creating behaviors in the system. And based on our data model that we standardized across the whole system, we were able to identify which signals and which behavior was associated with each signal and simulate them so that based on the reaction of the IDs and the time tag of the different signals, we were able to validate the correct behavior of the different components of the system. And the third setup was the local HMI and data gateway. So based again on the same SCD of the system, we were able to simulate all the different components of the system except from the station level HMI and gateway, and then simulate all the signals. And once again, with the data model and the standardized data model that we established during that new architecture, we were able to simulate the different conditions and create the different type test that we can do in order to validate the different functions of the system. So it's a loop that the gateway as well is not a proxy gateway because of a difference between the data model on the station level and on the remote level. But based on the two data models on the two networks, there was still some correlation to do between the two, and we were able to uh, validate the proper functions of the HMI. So all those three setups were actually, it's not, if you can skip go to the next slide, please. So the goal was to overlap across the different tests and have the same basis for that overlapping, which is the station SCD, meaning that based on the same files, the same file that was describing the system that was imported in DTM, we were able to validate that the exchanges on that SCD file was creating 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 the correct behavior on the ID sides. The IDs by themselves across the systems and going outside the station to the SCADA across the gateway. So that was giving us a complete validation of the system um, with overlapping conditions based on the SCD. So the automatic testing, so if you can, yes, to the next one as well. So the complete testing of the ID, we were testing the different relay settings. So the curves, threshold, tripping conditions, all the different alarms that we have. We're testing the hardware configuration. We're testing the Goose subscription and publishing, always based on that same SCD file, as well as the MMS. And we're also testing the different auxiliary functions, such as the disturbance fault recording, and as well as the test mode behavior. So all of those based on capacities of the IED. We were changing the test mode automatically, validating that all the data changes, or when receiving Goose with a test flag to make sure that all the proper security functions are applied and there's no mistake in the configuration of the IED. So this is not magic, it's something that was already done in most projects. But during the next step was the different validation of the Goose across the system. So there was different strategies that were adopted, mostly based on the capacities of the IDs. The UAL was well, is still a very flexible platform that allows us to have a detailed log of the different goose it receives and of the different goose it's sending, meaning that we were able to simulate all the goose that was exchanged, that was published on the network, and well, based on different functions that was implemented, the goose were disabled for one specific IED. They were replaced with the publishing across with the script that was developed in DTM. So now this script was simulating all the signals within that goose from that IED, and all signals were triggered sequentially at a specific interval, and the different behaviors were then either published within the log of some IDs, or the ComFed reports were extracted from those IEDs afterwards in order to do the analysis that the goose was well received and the behavior was according to the expected reaction of that IED. So we didn't have much choice to do the analysis afterwards because there was some log extraction that was necessary and that could not be done in real time. So the script in DTM was sequentially taking all the different goose that was published, that was saved in the SCD file, simulating all of them, and then we retrieve all the different reports, logs, comfeds that we can from the different IEDs, and we have a software that we developed on the side that helps us validate all the different goose exchange based on the time tag and on the different validated signals that allows us to have the results, whether the behavior was done correctly or not. You can change the next slide. We can see a bit of the results here, that we have the different signals that are published, and then sorry, they are analyzed, and we see the different delays in terms of receptions of the goose, of the treatment, and we do some analysis with color-coded results that while the behavior was as expected, or in some cases the behavior did not happen, and then it was flagged as such uh, in the different analysis. So we had some different results that were easy to read in order to speed up the validation instead of simulating the goose one by one and looking at the results. This was done all automatically for the goose exchange. The final setup was for the HMI. So for the next slide. So this was a closed loop between the DTM and the station level HMI and gateway. So all the IDs were simulated on the station network, and we were looking at the remote network in order to see the changes. So different conditions were simulated. The basic one was all pretty much all signals that were coming through the station network. We expected to see the same signal going outside to the remote network. Like I said, we had some limitation at the time so that we were on a device related naming on the station network. However, we wanted a function related naming. So this was implemented on the remote network. So the device related naming on the network was done so that it was close enough to the function related naming on the remote level so that we could do a correlation between the two. So it was not a perfect match between the ingress of the gateway and the egress, but it was still close so that we could do a pretty good validation of all signals. We also had different conditions that we wanted to validate, such as grouped alarms or different alarm lists. So those could be identified always based on our data model. And so those conditions were identified by the scripts. They were I could say compiled. So the list of signals were compiled, and the group signal could be deduced based on the model, all based on those scripts. So they were validated automatically based on the different scripts that we have. We also had a best of function, so it's a merge of the A and B signals. For the operators, they only wanted to see one set of information. However, it was acquired redundantly. So this merge had to respect multiple conditions. So it was not a simple logic or. It had to take into account the quality, the different conditions of the IEDs. And based on that, the treatment and the validation came with specific conditions to test in order to test that all the signals were well defined. So this is another condition that was evaluated during those loops of script testing that was done. So we can see a bit how the result was going on the next page. So we had all the simulated signals that were logged from our script in DTM. And at the same time, all the received signals were logged as well in CSV files. Those two files were input in our in-house software. That was easier to do the analysis in there afterwards, and it was giving us a result file where we had the different validation at the bottom in green and yellow based on the presence of the signal. So if one of the signals is simulated, we should expect to have the same one on the other side. So that was the case. We checked that the data set was the same while going through the gateway, that the quality, the value of the signal was the same, that the name here it's checked in yellow because of that difference between the function related naming and device related naming. But all those checks were done for all of the signals. So it was a bit the more thorough validation that automatic testing allows us to do instead of the manual one. We usually just check the value of the signals, but not all those attributes. And well, all that validation was done in a couple of minutes for multiple thousand signals, so it was much more efficient. So we can see on the next page a bit the difference between the product related naming and function related naming. So it is close, the logical nodes, that attributes, that objects, we kept it the same. So it was on the logical device that was not the same, but we could do some parallel. But the rest was translated as is. So for the different grouping, same, we had the conditions, we could test it, but it was mostly what DTM could allow us to do was to have scripts that allows us to really tailor what conditions are simulated in order to validate for our specific needs, which was pretty much the only solution out there that we saw that could be done. So for the next slide, I unfortunately I changed responsibilities, but we had some other developments that was um, that was planned for that automatic validation, which was mostly the controls at the local HMI and remotely as well. So the capacities were there. We just missed time in order to develop this. But with the validation of the IEDs or even with the real IEDs, it would have been possible to simulate the commands. And we were looking as well at different image recognitions softwares to complement it in order to validate that the position for a breaker, while we could do the remote commands automatically, and the local ones would be done by someone that tests, but they would be accompanied, sorry for my English, while taken by the hand in order just open the breaker. And then with the automatic testing, we would be able to validate that the position of that said breaker would change at all levels with all the different correct attributes. And when doing commands remotely, we would be able to validate at all levels that it's done correctly. So that would have helped to really validate the only missing piece that we did not do at that point. So when we rolled out these automatic validation, we we focused on those different topics in order to make it so that the deployment would be smooth. Was that it needed to be easy. So we made sure that the setup of the system, the rolling out of the different scripts, and the analysis of the results were done in an easy manner with clear results, with the report being easy to understand and to deploy. It had to be documented, so as always, proper documentation is key in the smooth deployment of any solution. So we made sure to explain how the process was going, how to set it up, and how to understand the results. And the accessibility, well, with the new architecture being a virtual machine that we could deploy, um, this tool was able to be deployed automatically when deploying the different virtual machines for each of the system. So we were able to deploy that automatic validation much easier across all the different installation, whether they were in FATs or if they needed to do it as well on site. So because of those, it was deployed, and up to now it's still used. So it was, if you can switch to the last slide, the so the this validation was the same strategy. It was a unified strategy to be deployed for every team that deploys the system up to now. So the way the system was to be tested was unified, so there was no dead spot in order to speed up things. The process was clear, and all the steps were well documented in order to apply it. It reduced the different costs and validation. Most of the testing that could be longer could be done overnight, or else it was taking minutes instead of hours. So it reduced the cost that we had to deploy the different teams during FATs or during commissionings. And the else built software was, well, it's still in use in order to be able to analyze all those results and still do updates in order to have a common portal for everybody. We still had improvements that could be done on that system. The main one was to integrate the validation tool in DTM. So, with the scripts and the analysis, it could have been done so that we don't have to rely on an external tool in order to validate. There was some limitation at the time in order to put everything in DTM. And like I said, the image recognition for the validation of HMI would have really complete the picture for the really complete validation of the system using DTM. So thank you. And if you have questions, I'll be happy to answer them.
Thank you, Renaud. Does anyone have any questions? We've got one in the back.
When you said you were validating the IEDs, the injection test systems, did you control that with DTM, or how was that run? Just in a traditional manner, or involving your new test setup?
Yeah, so this was more traditional. So it's the only component that was not using DTM. So it was the specific test set software that allowed us to do it. I think it was done a bit more thoroughly than what was done previously at Hydro-Québec, meaning that we were validating as well the behavior of the IEDs based on the Goose publication, subscribing, and the MMS reporting as well. Something that beforehand, I think it was just the behavior of the IED and not with its communication components validated at the same time.
I'm sorry, this is Jim Coates with Triangle Microworks. You may not have a video here. Going forward, will you continue developing this? Like the improvements that you're talking about, are those planned in the future?
I changed teams since then, so I think they're still using the DTM for the validation. However, I'm not sure how they're planning or if they did any improvements since then. I don't think they did the image recognition validation. I think they're still doing that by hand.
Okay. Well, Dave Goetner's here, and maybe we can get in touch with you and talk about if that's some things that we could help you develop and integrate as part of the tool, both
Mhm.
for like automating the controls that you were going to do and that image recognition, may be something that we want to add to it as a feature in DTM.
Sure, sure. Well, I'm sure not only Hydro-Quebec would be interesting if that can be set up easily, and it always comes down for specific, I think, customers that have always the same graphic representation. But if it's a function that's already there, it can probably be helpful.
Great.
Any other questions? Okay, I think that's everyone. Thanks again, Renaud, for your time. We are a little bit ahead of schedule. So what I would say, we want to just take 5 minutes if anyone wants to get some snacks and coffee in the back, and then we'll just regroup and move on to the next presentation.